for them if they stay in the pond. If you're in a high mountain area, you have wide swings in temperature. High altitudes can be fairly dry, not too good for a salamander. If you stay in the pond, you might have a better life. The same thing with a pond in an arid area. If you come out of the pond, you're going to risk drying up. So it would make sense then, under those ecological conditions, that the individuals are remaining in the pond and becoming pedomorphic. Right? So they're going to maintain their larval traits of having the gills and everything else that goes on with an aquatic existence, but they will become sexually mature and be able to reproduce and carry on the species. Another factor that sometimes comes into play is the abundance of fish. Some species, when fish are not abundant, will stay in the pond, become pedomorphic. If fish are very abundant, fish are predators, those tadpoles will metamorphose and come out onto the land. That might make a good subject for a term paper, facultative pedomorphs. There used to be a lot of information on it. I'm sure there's probably something new. Enough stuff in the last 5 years to make for a good term paper. So in general, they're all going to go through this pattern of changing hormones, and they are going to metamorphose. But we do have certain groups that are obligate pedomorphs. They will never metamorphose. And we have certain species within those two families that are facultative pedomorphs. Depending upon the conditions in their pond, they may metamorphose, they may not.
So then, in the example you gave about the fish, if they're abundant, then they would not retain those juvenile characteristics in their adulthood, the salamanders?
They would be better off leaving the pond because then they don't have that predator to contend with, the fish. There are some other examples out there, other chemicals and stuff. I haven't been in the literature in a long time. Those are just examples. Right? But some of our local species, you can play with them and you can force them to become pedomorphs or have them metamorphose depending upon the conditions in the aquaria that you're keeping them in. All right. Okay, one last thing then on amphibians, and we'll move on to reptiles. And that last thing has to deal with declining populations of amphibians. So this is something that was definitely noted beginning probably in the 80s. Worldwide declines in certain species, many different species of amphibians. It probably has been going on much longer than that, probably back into the 50s and the 60s, and it is currently continuing. So we are having declines in population levels, and some species are going extinct. So in general, it is a worldwide problem. So worldwide decreases in the diversity, the number and diversity of amphibians. And there's a bunch of possible reasons. Most are human related. Loss of ozone from the atmosphere. Humans over time release certain chemicals into the atmosphere, chlorofluorocarbons, CFCs in particular. Things like Freon or CFCs, is a CFC. Gets released into the atmosphere, the end result is that there is a decrease in the amount of ozone in the atmosphere, in the upper atmosphere. Ozone will absorb a lot of ultraviolet radiation. The release of the CFCs causes a reduction in the ozone. That causes an increase in the amount of ultraviolet radiation that is striking the Earth. That has a detrimental effect on the larvae and the eggs of many different species of amphibians, that increase in ultraviolet radiation. Acid rain, another human-caused problem. So when you burn fossil fuels, coal, oil, certain chemicals are being released while you do that burning. Chemicals like nitrous oxide, sulfur dioxide. Those chemicals will rise up into the atmosphere, combine with water, and form acids. When it rains, those acid molecules come down to the earth. They accumulate in the breeding ponds where these animals live, and ultimately you get the death of eggs and tadpoles again. The significance of the problem varies where you are, because some of the, depends on the geological nature of your area. The rocks in some areas can buffer that acidity, and so the pH of the breeding ponds isn't changed that much. In other regions, they have a different kind of a geology, and the rocks do not buffer that acid as much. So you go to New England with a very rocky type of area. They have a more severe acid rain problem than we do here with all of our sand and gravel that seems to buffer that acid rain a little bit better. Oh, what else? Global warming. Despite what the Republicans say, it is happening. There are changes that are occurring as far as our climate goes. We don't really notice it too much around here, the effects on amphibians, but you're starting to see effects in, let's say, mountainous areas. So in mountainous areas, these animals are adapted to the cooler environment, and as global warming occurs, they can't go anywhere. They're stuck on these mountains, and they are not adapted to those warmer temperatures. So we are losing some that way. That problem will continue. And remember, you always have the problem of when water warms up, there's less oxygen available. Fungal infections. This one's very bad. There's a particular kind of a fungus that's causing problems with amphibians. And it's called the chytrid fungus. And it's called chytrid because of the phylum of fungus that's involved. So, Chytridomycota. So when a lot of times you can read an article in the newspaper or magazine and they'll just say chytrid fungus. Well, it just means a fungus that is in the phylum. Is it phylum or order? Phylum. Chytridomycota. And there's one in particular, one species in particular. You don't have to know the name, scientific name. So I obviously don't. Chytridium. So one particular fungus within that phylum is causing a lot of problems for amphibians. Batrachotrypterium dendrobatitis or something like that. I just forgot it all. This fungus has spores that are released into the water. They're motile, they can swim. They make contact with an amphibian, and they set up residence in the skin of the animal. that spore will develop into the fungus, and so you have hyphae, the vegetative part of that fungus, spreading out through the skin of the animal. That fungus then causes problems with water balance and respiration as far as the frogs and toads and salamanders are concerned. All right, the skin of those animals is very important for respiration. We already saw that. All right. The fungus screws up water balance and it screws up respiration, and you get dead animals. Yeah.
Why does this become a problem though? Is it a temperature variation or is it because it's not
Introduced. That's like many other things. So there's ways in which it can be introduced. One, not as common. I'll mention the common one in a minute. Frog legs. So things like your bullfrog has been transplanted on different continents, and so you have movement of amphibians to different continents carrying their diseases with them. Pet trade is another. People have their pet and they go, well, I'm going to let it go. So even though the frog came from Africa to begin with, you let it go in a pond in Michigan and it can transmit diseases. One common way I think that most people think that this problem occurred is that frogs used to be used in pregnancy tests. And I believe it was Pipidae, Xenopus, that was imported from Africa and it was used in pregnancy tests. Many of those frogs would escape and get out into the environment. And I believe that is the species that probably has transmitted this fungus more than any other. In addition, you can just get people walking through the environment, biologists working in a marsh, and they've got their waders on. They pick up spores on their boots. If they don't clean their boots before they go someplace else, they can transport it.
Does this affect salamanders as well, or is it just frogs?
It does affect salamanders as well. So it's all amphibians that potentially can be harmed. And there's a big variance in the how affected they are. So some show resistance and are not affected very much at all. Others are being devastated and going extinct. That's another good subject for a term paper, is any one of these ideas. And habitat loss is another problem for amphibians. And you can see that yourself. I mean, just look, anytime construction is going on, if there's a wetland, that wetland is getting filled. Amphibians, by and large, are reliant on wetlands. They either live in the wetlands all the time, or they need that water in order to lay their eggs. You destroy that habitat, remove that habitat, then there's no place for that animal to live. So every time we build shopping centers and highways and things along those lines, we're reducing the amount of habitat, which then reduces the number of amphibians in the general area. So it is a worldwide problem. You have a decline in numbers, you have a decline in the diversity of amphibians, and there are multiple reasons for that. And unfortunately, they're all human related. Questions? Okay, we'll start on reptiles. If we look at the classical taxonomy for these animals, what's in your course pack? We're going to be dealing with the class Reptilia. Subclass Anapsida. Which contains the order Chelonia. Who's Chelonia? Yeah, turtles. So anybody that did actually look at them the Wednesday before break